Hi everyone and welcome back to this series. So this is the lithium ion cell capacity checker. The next thing I want to do is add a Tact switch, Tact button, to this little setup here. And the reason why I want to do that is because I want a start button, a pause button and a stop button. And I suppose that would enhance the user experience, if you like. So we'd put the battery in, this would say welcome or something like that, I don't know. Then we press the button and that would say to the Arduino, start the drain. And then if we were to press it again, I want it to pause, and then if we press it again, I want it to stop. And terminate. Now I'm not exactly sure why I'd want to terminate at the moment, but if we just do that anyway, that'll be cool. The next thing I want to do as well as that is I want this to be like a status LED, so I want another LED. So this one is going to be off if it's not complete and on if it is complete. This one here, the new one, I want this to be draining. So we'd have that plugged in there or pushed in there, and as soon as you press this to get this thing to drain, this will glow. And if you pause it, it will not glow, and if you stop it, it will not glow. So that will go in there, however it will go in exactly. When you press start, this will glow, and then when it's finished it will stop glowing, and of course this one would then glow instead. So that's what I want to do. So I've covered three things there. So I think the first thing I'll do is wire in this little LED. So we've got an anode and a cathode, and the anode goes to the pin of the Arduino and the cathode goes to ground. Now there's something quite cool that I suppose I'll show you. This is how I remember which is the cathode and which is the anode. If you imagine we've got a plus, obviously denoting plus, and a minus, denoting minus. If you were to get the two lines, if you like, with the plus, and we've got a line there, and then we put the other line, this vertical line here, at the side of it, we get a long line. Whereas if you put the lines together in the minus, there's only one line, and it's like half the size. I don't know if that makes sense to you, but that's how I remember which is the anode and which is the cathode. So the longer piece, imagine that that is the vertical and the horizontal line. Put them together, and therefore the plus is always longer and the minus is shorter. So that's how I personally remember how to identify the anode and the cathode. I just thought it would be quite interesting. Anyway, back to the project. Let's push this back. So very simply, I'll just push this into a pin, and let's say D5 to the ground rail. Now, if you remember on the last video, it might have been the one before, I pushed the LED, the other LED, into the ground line, the ground rail, and I've got a resistor going back to ground. Now we can use that now, so we don't have to mess about with ground because we've already dealt with that, because we've already got a resistor in the ground rail. It's just dawned on me that actually it's probably about time to change the cell, because I've discharged that other one quite enough. So yeah, I've changed the cell to this Sony 18650, and now it's time to carry on. So I've got this Tact switch, and like I said earlier, this is going to be able to set the mode, like whether it should be discharge, pause or stop. So where's this going to go? This might be a little bit awkward actually. We can't put it in there because there's something using that rail. Can't put it in there because there's something using that rail. We could use the bottom rail here, but then it won't reach anywhere, so we can't use that one. We don't want to put it there because the wires will block the LCD. Let's say it's a little bit awkward, but let's say there. It's only a little prototype on a breadboard anyway, so if I was to make this into a real PCB, of course, we'd lay them out more sensibly. But anyway, so push the little Tact switch in there, and I'll just zoom in so you can see. So hopefully you can see that there. Now where are my wires? We need a ground wire. And is it going to have to be quite long? No, not really. So a short ground wire. I always use blue for ground. And let's push that in there. So we've got ground here. I can just push that in. So we'll say ground there. and the other one needs to go to a data pin, which it looks like D4 looks free, so I usually use yellow for data. So let's go for D4. D4 to the other pin, which is here. Actually, I'm going to switch those around. I'm going to put the D4 pin there, and I'm going to put a ground there, just because of the distance of the wires. So there we go, I've got the button now, and now it's time to go over to the PC. Right, so the first thing we're going to need to do is add the new pins. So if I just copy this define line here, so 1 and 2. So one of them is going to be called the draining LED pin, draining LED pin, and that's going to be pin 5, I think it was, yeah. And the next one is going to be called the switch pin. So switch pin, and that's going to be pin 4, if I remember rightly. So what we need to do now is just replace this, because LED pin doesn't really make sense anymore. So replace with, what do we call it? Complete LED pin. Complete LED pin. So replace that there. Find the next one. No. Yes. Replace that one. Find the next one. Yep. Replace that one. Are there any more instances of that? No, there are not. So that's that done. Now the next thing we're going to need to do is to change the input output. Well, specify the pin modes. So we've got the complete LED pin. We need to paste twice. So we've got the draining pin. Draining LED pin, and we've also got the switch pin. The switch pin. Now, the switch pin is not an output, it's an input into the Arduino, and therefore we would write input. But it's not an ordinary input, it's input pull up. And input pull up, I suppose it's a bit peculiar, but if you notice the way I wired the switch, it was a bit weird. I connected one side to ground, and I connected the other side to the pin, which was pin 4, I think it was. Now that's a bit peculiar. So you've got a pin which is basically switched to ground. And I'll try and explain briefly what's going on here. So the switch in the middle obviously connects the two, or connects the pin to ground like I've just said. But when the switch is up, or in other words open, then what happens? Well, basically the pin is a floating voltage. It's floating. So it's technically neither high or low. It's just floating. So what this says here is input pull up. So if it's floating, or in other words, if the Arduino can't detect a specific high or low, then pull it up, or in other words, just read it as high. So if it's floating, read as high. In other words, read as high by default. So what happens is when we press the switch, it specifically goes right down to ground, it shorts it to ground, and there's a strong enough signal there for the Arduino to detect that it's a definite low. So that's what's going on there anyway. So that makes me think that we're going to need another 2 variables. Because we've got the switch pin, we want to be able to switch between 3 different states. We want to say go, or on, or drain. We want to say pause, and probably we want to say stop. So here you can see we've got this on variable. It's set over here somewhere. Yeah, bool on. I think it's sensible to change that to drain. So Control and F, and let's change it to draining actually. Draining. So let's replace, find the next one, replace, find the next one, nope, find the next one, replace, and find the next one, replace, and that should be all of the on variables done. So we've got this bool draining. So we want draining to be off by default. So when you turn the Arduino on, we don't want it to drain straight away. So we'll get rid of that line there and save that. So draining is off or false by default. So in the loop, if it's draining, then do all of this stuff. Then if you're doing all this stuff and the battery voltage dips below 3, then automatically change draining to off. In other words, don't drain anymore because we've reached the voltage that we need. And so far so good. So let's expand on this now. So we want draining to be false and we want complete to be true. So complete equals true. Now technically we don't have to have these variables, but I thought it would just be better basically. So yeah, complete, and we need the variable for complete over here. So complete of course will also be false to start with. Draining complete. So let's go down. Of course, when this is draining, we want to be able to show the draining LED. Or when it's complete, we don't want to show the draining LED. So, if it's draining, the complete LED would be low, of course. So if draining, the complete LED will always be low. Now if it's draining, the draining LED would be high. So where's the draining LED? Where is that? Draining LED pin. That would of course be high because we're draining. So I'll just paste that below there. Cut that and put that in there. And draining will of course be high. And then down here, if we've completed, because we're saying the battery voltage has gone 3 or below, then we've completed. So the complete pin would be high and the draining pin would be low. Draining LED pin would be low. So what this should mean is that of the two LEDs, only one LED should be shown at a single time. So either it's draining or it's complete. Or technically no LEDs could be showing because it may not be draining and it may not be complete. So moving on, so we've got the draining and the complete variables. But in the loop, the first thing it checks is it draining? And if it's draining, it does all the stuff, it sorts the display out and it of course drains. And then when it goes here and it's no longer draining, or in other words the voltage is less than 3 or equal to 3, it effectively switches the draining mode off and switches the complete mode on. And all that currently does is set the complete LED pin high. We don't actually have to put it there, it could be in a separate section. Well anyway, the point is, when it completes, then this code no longer gets run. So what we need to do is have another if. So if it's not draining, we go down here. I think it will be here. Yeah, if draining. So we'd say if complete. So if it's not draining but it's complete, then do this instead. And this is where our code is going to be for the completion stuff, to say, okay, this cell has this much capacity. So you know, complete LCD stuff here. Control T, Control S. Now at this point I'm going to make a few changes. I'm going to move these here. So if it's complete, we turn the transistor pin low and we set the complete pin high. And I'm going to put those over here. It just seems to make a bit more sense, that's all. So yeah, when this is complete, when it's running, well, you know, when it's draining and it's complete, then we set the draining pin low, and then after that, when it's complete, we move over to this code here. Now this complete bit here, which shows the ending stuff on the screen, I'm going to go back to that in a minute. But I mentioned about the button that we could have start, pause, and, well, you know, depends how you want to say it, but start draining, pause, resume, and complete. Now I'm not exactly sure how I'm going to work with that yet. I think it's probably best though if I have a pause variable. So up here we've got draining, complete, and we want pause. So pause, oops, Now, again, there's lots of different ways of doing this. You could have pause set true at the very start so that nothing happens and whatever, but I'm not going to do that. I'm just going to keep them all false. And then over here, let's say loop. Right, so if it's paused, then, I don't know, pause stuff. Else, if it's not paused, then if it's raining, do that, and if it's complete, do that. Okay, so if it's paused, don't do anything. Else, if it's not paused, then if it's draining, then do that. Then you could do an an else over here, not an elf. But I'm happy like this. So if it's raining, do that. If it's complete, then do this. Okay, so next there are two more things, two more important parts of this code which we need to do. The first one is the timing. Now this delay thing isn't really going to work so much anymore because we need to change the amount of delay to be able to recognize user input. And the other thing, of course, is to be able to actually get the user input. Now, to get the user input, it's maybe a little bit complicated. Well, in fact, both of these little steps may be a little bit complicated. But what you have to do is remember an old state of the pin and then remember the new state of the pin. And if the state has changed and the state is now low and it was high, then you know that the user's pressed the little switch. Okay, so I've just pressed Ctrl and R in order to compile this sketch, and this will just make sure that there are no problems. And there actually is a problem. If paused, and it's saying pause was not declared in this scope. Right, okay. So let's just go up here, and it's easy. It's because there's no D on paused. So Control T, Control S, Control R for compile, and let's just check that this is working now. So I'm going to stop this portion of the video here. We've got two things to work on next time, and that will be the two things I've just mentioned just earlier about getting user input and changing the timing. Now in that thing, I suppose if you're interested, you might learn those two things. I've actually done tutorials about those before. There's a tutorial about Arduino timing, and there's actually a tutorial on how to get user input into the Arduino too. So I'm going to be probably touching on or covering over the material for both of those tutorials. But there you go. We'll leave it there for today. Thanks for watching. Bye.